In this video I will show you the progress that is made on the development of the Bigbot Path Controller. Here is a model of the Bigbot. It's a model with a camera dome and it's a green version. I just used this UEDF model for a simulation. I made a simple kinematic simulator to test the path controller that I made and that moves the robot around given the velocity command it receives. I made a path generator and a path executor. The paths that I generate are circles and straight lines. That is all. I do that on purpose. I want to be able to specify a minimum radius that is not too narrow, so I know the Bigbot does not cut corners, which may lead to problems when it is towing some equipment. If you want to tow equipment for spraying some crops, or when the Bigbot is pulling a dragnet across a football field, in those cases turning the Bigbot on the spot is not a good idea. This will lead to a jackknifed trailer or tangled dragnet, so minimum radius, good thing. Furthermore, the paths are not only a combination of circles and lines. I want to be able to define absolute paths, so with longitude and latitude, so I can reuse them. Actually, I store them in a database. If I want a local football park to be swept, I can load the relevant paths with the latitude and longitude and execute it. The controller, by the way, is an L1 controller, as it is called in ArduPilot or PX4. If you are more into nav2, the controller is called a pure pursuit controller. It is exactly the same thing. I think the paper from L1 from Sang-Hook Park from MIT was first. It was published in June 2012 already. Anyway, I implemented the controller and made a simulator in which I can add some rotation disturbance and then observe how it is corrected. That all seems to work very good in the simulation. I use ROS2 because I like the DDS middleware and the philosophy, but I don't use nav2, the navigation framework. I want something that is more simple, so I developed something myself, that is, the path executor and the path planner. As you can see, we have a black stick and a red stick. The black stick represents the start location and the direction of the robot, and the red one the end position. Now, the direction of the black and red rod is the begin and final orientation of the robot. When I move them around or change the orientation, I can derive any path from the black to red. It needs a maximum of 3 path segments to do this. This may be a combination of an arc, a straight line and an arc. This is the case when the robot is moving forward all the time. Or it may be 3 arcs when the second arc is traveled backwards. This is well known by backing your car out of a tight parking spot. Actually, you can derive different solutions to this graphical problem, but the GUI shows only one path. That is the shortest path. Now this path generator GUI is just for testing, so I have been experimenting lately with different localization methods for outdoor. They all involve GPS and sensor mixing of different sorts, with a camera or LiDAR to get a good estimate of the position. So sensor mixing leads to an improved pose estimation. Using this pose estimation with the controller and path planner I made should lead to good results. So now regarding the path generator and the path executor, I think they are mature enough to be tested on the Bigbot. Of course, the proof of the pudding is in the eating, so I need to go outdoors for some real testing. The weather last month was really horrible, just pouring all day long, so I hope I have a window of opportunity the coming time. So hopefully I can give you an update in a few months with some live footage. Until then, goodbye.